Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're talking about linear sequences and in particular the term-to-term rule. Let's start where we left last time, where we started generating these linear sequences from pictures. So here's a set of pictures. I just want you to fill in the table with the picture number and the number of matchsticks in each picture. Pause the video and complete the table. Okay, hopefully I would expect you get the following. The first picture has 5 matchsticks, the second 9, the third 13, the fourth 17 and the fifth 21. Hopefully you spotted each time you were adding 4 matchsticks to the picture before it. So each time to get from what we're going to call term to another, you add 4 like this. Now these are where we've seen these what we call linear sequences arise. We're going to start now by not worrying about the picture anymore, and we're going to start by concentrating on the actual sequence, which is this list of numbers here. And probably in future we're just going to consider them as a list going horizontally across the page like this, and this is henceforth how we're going to really deal with them. And we're going to talk a little bit about them, some of the key terminology you need to learn, and how to deal with these type of sequences. So let's start by considering this very one without the picture anymore. So that is the exact same sequence there. To start with, what on earth is a sequence? I'll write these all out later, but just to say, a sequence is a list of numbers that follow a rule. Okay? What's a term? How about I show you terms by pointing some out? That's the first term, the second, the third term, the fourth, the fifth term. Could you tell me what a term is? A term is just a number in the sequence. Simple as that. Now, term-to-term rule. Remember we said a sequence is a list of numbers that follows a rule. What's the rule with our sequence here? We've already talked about it. Each time you add 4 to get from one term to the next term. To get from 5 to 9 you add 4. To get from 9 to 13 you add 4. To get from 13 to 17 you add 4. And to get from 17 to 21 you add 4. So the term-to-term rule, the rule to get you from one term to the next term, in this case, is going to be add 4, as follows. Okay, and that's what the term-to-term rule is. Why is that useful? Well, it's really useful to know the term-to-term rule because you can predict what the next term in the sequence is going to be. If I asked you what the 6th term is going to be here, you know you've just got to take this term here, 21, and add 4 to it to continue on the sequence, and you know you're going to get that the 6th term is actually 25. So having talked about all this, let's just move on, and why don't we summarize the 4 key definitions we've already learned. So I need you to write this along with me. What was a sequence? All a sequence is a list of numbers that follow a rule. Simple as that. So let's write this down. Now, what's a term? A term is simply one of the numbers in the sequence. As simple as that. So what's the term-to-term rule? Well, the term-to-term rule in this case was add 4. What it is, it's the rule to get you from the term before to the next term. It's as simple as that. And lastly, this is really important, what is a linear sequence? So what about the one above makes it linear as opposed to just being a sequence? Now a linear sequence is when you add or subtract the same amount each time for the term-to-term rule. The term-to-term rule here is add 4, add 4, add forward 4 forever, or you could be subtract 3, subtract 3, subtract 3, subtract 3 forever. So it's when you add or subtract the same amount every time for your term-to-term rule, and that's what makes it a linear sequence. So let's write that down. A linear sequence is one where you add or subtract the same amount each time in the term-to-term rule. Okay, so a sequence where you add different amounts every time wouldn't be linear, but that's what makes that linear. Great, so we've defined all the things we need to. Now let's get on and try some questions. Right, example. Let's do this one together. That's a linear sequence. Just out of interest, why is it linear sequence? It's going up, this one, and it looks like it's going up by 6 each time. So that's why it's linear. It asks us to state the third term. Remember what term is? It's the number in the sequence. This is the first term of the sequence, that's the second, that's the third, that's the fourth, and that's the fifth. So the third term we can clearly see is 25. We're just asked to state it, we just write it down. What's the term to term rule? Each time you're adding 6, aren't you? So the term to term rule is add 6. Is 42 in the sequence? Well, it's not in this list of numbers. To check, we know that you add 6 each time. So why don't we add 6 on here and see what we get? If we add 6, we would get the next term is 43. If we add 6 again, clearly we would get the next term is 49. Now, you keep going up, obviously, as you go along. Now, 42 is in between 37 and 43, so 42 is not in the sequence. So the answer to this is simply no. 43. Actually, the best way to state this is to state the 2 either side of it. You would state 37 and 43 are. So therefore, that's obvious that 42 can't be. And we're done with this question. Now, at each stage, you should pause and try all of these yourselves. So let's do another one. Pause, have a go. We're asked to state the fifth term. 1, 2, 3, 4, 5. The answer is 1. The term to term rule. This time the sequence is going down. Each time we are subtracting 3. I hope you can see that. So the term to term rule is subtract 3. What would the next 3 terms be? Well, we have to do 1 subtract 3, which would be negative 2. We have to do negative 2 subtract 3, which would be negative 5. And if I was doing one more, the next one would be negative 5, take away another 3, it would be negative 8. So let's state negative 2, negative 5, negative 8, and we're done with this question. Next one. Pause the video, have a go. Now the term to term rule here. How do you get from negative 3 to 5? Well, you add 8. That's maybe not the easiest one to see it from, so maybe if you didn't want to deal with that one, you just look how do you get from 5 to 13. You add 8 each time. You can see that. So the term to term rule is simply add 8. What would the next 2 terms be? Well, if I add another 8 here, what would I get? I'd get myself 37. If I add another 8 after that, I would get myself 45. So we would write here 37 and 45. And what would the first term have been? This here would be the first term. Now, if I'm going and moving along to the right, and each time I'm adding 8, to go backwards, I must what? That's right, subtract 8. Okay, so it's negative 3, take away another 8 is going to be negative 11. And you can check you got it right. If you take negative 11 and add 8 to it, you do get negative 3. So the next term would be negative 11. Okay? And that's pretty much it for this particular video, other than to leave you with a little puzzle. Suppose I asked you, is 581 in this sequence? Is 581 a term in that sequence? I wonder if that's causing you some problems. It's certainly causing me some problems because I'm thinking to myself, to check that, I'd have to keep adding 8 from 45, and to be honest with you, I don't want to be here all day doing that. That's a long process. So the next set of skills are going to be us finding a way or a formula or what's called the nth term of a sequence to be able to answer these type of questions much easier without having to use the term to term rule and just count on all the time. So in the meantime, you could have a think about that and think, can you get there a quicker way than just adding 8 on each time? But that's it for now. Tune in for the next video to see how to answer this style of question. Thanks for watching.